All right, on Mars we also see clouds. We have different types of clouds. We can have clouds made of different things. We can have water ice clouds, which we have on Earth. You see the really high, thin clouds, those are ice clouds on the Earth. Same thing like you see here. They're ice clouds. We can have carbon dioxide clouds, meaning it gets cold high enough up, the carbon dioxide freezes into little droplets, which make these clouds as well. And we also can have dust clouds. Dust clouds occur when there are weather patterns on Mars that actually, you can get winds that cover the whole surface of the planet for months. And then all of a sudden it'll clear up, and one day all the dust will just fall out and it'll just stop. So if you're going to live on Mars, you have to be able to deal with all these weather conditions. That's one of the things they're doing right now, is exploring all the weather on Mars so that if they send humans there, we can understand what's going on. This is Olympus Mons, and you see these are clouds. Olympus Mons is so high, it's almost sticking out of the atmosphere. The atmosphere is super, super thin up here at the top. So the clouds actually form below it. It's like sticking through the clouds. All right, evidence for water. So you got to look at this. This is kind of tricky here. You see this? This is a river valley on Earth. Hey, those look very familiar, don't they? This was a river valley on Mars, and it was actually created by water, flowing water. This is just comparison showing, yeah, on Earth we have a similar thing, where water flowed from one place to the other. We have tons of evidence for liquid water on Mars. Here's another one. This is a river delta, 100 kilometers. Remember, this is about 60 miles. So this is very large. So where a massive river flowed out and then let all its debris out. Kind of like Louisiana, where the Mississippi hits the Gulf. It's been getting bigger all the time because the Mississippi is taking all this dirt and stuff and depositing it in the Gulf as it hits the ocean. Same thing happened here. This is a river delta from Mars. Now it looks a little weird because the lighting's from the bottom instead of the top, and so it seems like it's sticking out instead of sticking in. It's just the way the lighting is, but that's what it is a river delta. All right, then we have more evidence of water occurring even while we were watching Mars in the last few years. You see this right here. This is the edge of a crater, and they were taking pictures of it right here. And you see this right here and all this here? What happened is they realized there was ice underneath the ground, and then that ice melted and turned into water. Now it's under the ground, so it didn't immediately become a gas, and it flowed under the ground, but you can see the evidence for it in the surface. So there was a phase change of the water ice underneath the ground as it warmed up for a short period of time. All right. Here is another one. You see this is right on the edge of here. This is the Tharsis bulge, the blue part right here. This is Holden Crater. If we go right here, you see this? This is a river. An old river that flowed through here. So there's tons of evidence for water on Mars. We know water on Mars. And not only that, we know Mars has a lot of water tied up in ice in the polar caps. If you can melt the polar caps on Mars, both polar caps, you would have enough water to cover the whole planet by 3 or 4 feet of water easily. So there's a lot of water still there. It's just frozen. Frozen under the ground in permafrost conditions. All right, so that's what happened. We also have seen more active things. You see here, this is on the edge of the permanent ice sheet. So this is the permanent ice sheet right here, water ice. But this shows an avalanche. You see that it's kind of hard to see here, but this was an avalanche that fell down. Essentially, the ice broke off, fell down, and then this is the dust dispersing from that while they were watching it. So Mars is geologically active. Most of the planets we watch over time, you don't see changes occurring day to day. Things are pretty much the same. All right. Let me show you. We'll come back to that. See if I can make this work here. We also see a couple other things that are cool about Mars. work, sorry. But we see, let me do this one. Maybe this one will work. Yeah, here you go. We see dust devils on Mars, which is kind of cool to see. Dust devils are when you get this circular spinning thing. They're like tiny cousins of tornadoes. But they pick up the dust and they go spinning across the surface. And they can happen all the time. We see them all the time in, you know, any desert climate, Oklahoma and all that. Certain parts of it you can see this spinning across West Texas. And those are just dust devils, but it was cool to see dust devils on a different planet. All right, now I'm going to go back to here. We do have rocks from Mars. Not very many, only a few. We're like, how do you get rocks from Mars? Well, we got rocks from Mars because, not because we ever went there and we've never brought a rock back. Now there have been plans to try to do that, but it's a very difficult challenge. Instead, this is a meteorite that was found in Antarctica, which is a rock that falls from the space, lands. And Antarctica is a great place to find them because you walk around on the ice, you find a rock. It didn't come up through miles of ice, it fell from space. Well, when they analyzed this, they would look at pockets of gas that were trapped in there, and those pockets of gas had the exact same density and composition as Mars, which could only happen if that rock originated on Mars. And so what we think happened is the large impact crater occurred on Mars. Some of the rocks actually had enough energy from that impact that they flew off of Mars. They escaped its gravity, floated around space, and eventually millions of years later ended up in the Earth's orbit, ran into the Earth, and we found it. Now when they analyzed it, they found this. This is what the electron microscope, this is super zoomed in. They found things like this, and they thought maybe these are fossils of ancient microbes. And so I got everybody excited, but then they realized that they were really tiny, tinier than anything we've seen on the Earth. And nobody actually looked at them on the Earth, and when we looked at them on the Earth, we found them too, and they didn't have anything to do with life. They were actually just structures created in the rocks, and it was just a natural process in the rocks, and it really wasn't created by life. So it was one of those things, oh, everybody was excited, but then they're like, no. So now, as of now, we currently don't have proof of life on Mars, but we're still looking. All right, so let's talk about terraforming Mars. Terraforming means to make Earth-like. That's what terra is, Earth, right? So we want to make Mars Earth-like. Well, remember Mars had water, a lot of water. It probably had seas and oceans, okay? At one time, in fact, Mars might have been a nicer place earlier on than Earth was because it was smaller. And Mars is in what's called the habitable zone. So let's look at this. Here's the sun. Here's the Earth in its orbit. This is Earth. Here's Mars. Here's Mars' orbit. All right, what's the habitable zone? Well, there is a region around the sun where if you're in this region in here, you can have liquid water. You're getting the right solar energy as combined with the greenhouse effects of an atmosphere so that you can have liquid water on your surface. Earth, we're in that obviously because we got liquid water all over our surface. Now we're on the inside of that zone. If you get in too close, you get too hot. Venus is in here too hot. But Mars is still in that habitable zone, meaning if it has a thick carbon dioxide atmosphere, you could have nice liquid water on the surface. What happened to Mars' atmosphere? Its thick carbon dioxide atmosphere. It probably had just as thick a one as Venus or Earth did early on. Very, very thick. And over time that went away. Why? Mostly because Mars is too small. Mars is too small, its gravity is less, it's 40%. It's further from the sun, right? And so over time, that atmosphere started to dissipate away. And once it starts to dissipate away, Mars starts to get colder. Once Mars gets colder, the atmosphere starts to freeze into the polar caps. Once the atmosphere starts to freeze, the atmosphere gets thinner, it starts to get colder. And so it kind of runs away until it gets cold and the atmosphere gets thinner and thinner. And that's what's happened over the last billion years on Mars. So Mars started out very nice, lush place, would have been great. And so that's why we still think there probably was life there, but it's all gone now. Unless it's underground somewhere, that's our only hope. And it probably was more just microbial life if it was. But we don't know anything for sure yet. All right, so the problem with Mars is it was too small. It couldn't hold on to its atmosphere. If our solar system had been formed differently, because remember, Venus is as big as Earth. If you had flipped these planets and put Venus where Mars is and Mars where Venus is, there would be now 2 planets in the solar system that both would probably be sustaining life. It would have been very interesting. But that didn't happen. We have the smaller planet out here, Mars, and the big planet Venus in here. Venus ends up runaway greenhouse, too hot. Mars ends up too cold. All right, so how do you terraform Mars? How do you make it Earth-like? All we have to do is warm it up. So we have to do it in reverse. If we could warm up Mars, then what would happen? Well, think about it. If you could heat up Mars, you start to melt the ice. You melt the carbon dioxide, it makes the atmosphere thicker. Once the atmosphere starts to get thicker, it starts to get warmer because it's a greenhouse gas, the carbon dioxide. And so once you get it started, it's going to actually start warming itself up. You're also going to start to melt the permanent polar caps where the water is. Water is actually a greenhouse gas as well, the water vapor. You start to have water vapor